Hello. I want to go over another leak code problem I was doing today. It involves searching um for a node within a tree and then returning um that node as like a subtree or like the tree itself. So in this case we have this whole tree right here with um 4, 2, 1, 3, and 7. Our target node is 2. So once we find it, we return 2 as its own tree with 1 and 3 still connected to it. Um, so yeah, let me get to it. Um, Same stuff as always. I haven't changed anything yet. Um, yeah. So uh, class solution is going to be a tree node. We're going to be returning a type tree node. And then we're going to be inputting the root of our tree and then the target value. Um, so first we want to say if root is equal to null. So this is our base case. Or root value is equal to null pointer. Sorry, not null pointer. Value. So this one is saying if we reach a null, like if there's no more leaf nodes, well, we return null PTR, meaning that we didn't find the value within the tree. And then this is if we did find the value in the tree. Um, Here we would root, return root. Um, then we would want to recursively check left and right side of root. So we're going to say if value is less than root value, return, and then recursively call the search. Uh-oh. Search binary search tree with root left and then value. Else return search binary search tree root right with the same value. So this is going to recursively um, call and check both sides of the tree, or at least one side of the tree, depending on if the value is larger or smaller than uh, the current root's value. So in this example, 4, 2, 7, 1, and 3. Um, say our target is 2 right here, like in the example, we would check the root first, check the root first, compare the value of the root, which is 4, compare if our target is less than or equal to 4, our root value. If it is, in this case it is, we would search the left side of that current root. And in this case, we found 2 with just one recursive call, and then we would return 2, 1, 3 as our new tree. Um, but let's make up some numbers right now. 7, 6, 8, 8, 7, 9, 8, no, um, 10. This is a 6. Um, 5. Oh, 5 doesn't go there. 5 goes here. Um, say 4. Let's make this a bit wider. Uh, yeah, just leave it like that. Say our target now was 9. 9. We would compare our target to the root value, which is 7. Um, uh, in this code right here, we would check. So we'd pass in our current root, which is 7, and then our value, which is 9. If root is equal to null, which in this case it is not, and or if root value equals the current value, return the root, which is not, this is not equal to each other. Then we check here. If the value is less than 9, is 7 less than 9? No, we don't even enter this. Else, meaning 9 is greater, or our target is greater than the root value, we recursively search the right side. So here we would go to here now. Now we pass 8 into here, because remember it's a recursive call. And then we pass in the same value of 9. Check if root is equal to null. It is not. Check if root value is equal to value. 8 is not equal to 9. We don't do this. Now we check the first if statement. If value is less than root value, in this case 9 is greater, our value is greater than the root value. We don't even enter this. Then we go into the else statement again. Come here, check this. Root, we would this would be true, so we would return root because root value is now 9. 9 is equal to 9, so we would return 9, 10, like that. So now let me show you that I'm not lying. Here I'm going to create a tree node function, tree node, add sub tree. I think it might be a void. Yeah, I think it is a void. Void add sub tree. We're going to pass in node root, and then that's it. Why up tree node? Oh, tree node. So our base case is going to be if node or if root equals null pointer return. Then we're going to say add node. So what we're going to do is calling this add node here. What I'm doing here is so I can create a new tree and it's going to add this the nodes of the separate um uh separate new root that we copied from the original tree. So here we would just pass in root value, and then recursively call add subtree, add add subtree root left, and then add subtree root right. And then we don't need to return anything after that. So that's pretty much it. Here I already have these numbers here. So I wanted to show you. Because I'm not using this. Replit doesn't like it for some reason. Here we go. So in the numbers I have here, let me erase this real quick. I have 5, 4, 3, 2, 6, 7, 9, 8, and 10. So I'm just going to comment this out real quick. So our target is going to say, let's say our target is 9. We're going to create a new tree node. tree node, new root, which is going to be, this is going to be our new root right here for the new tree, is equal to solution dot search binary search tree. And then we're going to grab the original root from the original tree dot get root. And then our value, we're going to input 9. So let me close this for a bit so we can see it. So now here what we're doing is we're searching through the tree, and we're going to input, once we find the 9, we're going to input this as our new root. Now we're going to say tree, new tree. And then since new tree has the add subtree, I'm going to say new tree dot add subtree, and then we're going to pass a new root, and this is going to recursively add all the variables after this node, all the nodes after this node back into the tree. And then we're just going to say new tree dot print tree. Now let's run it and hopefully this works. Here we go. Yes, it does. So here, in my example with my numbers, as you can see right here, 9, 8, and 10, 9, 8, and 10, null, 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 null. What it did here was, with the class, with this one right here, we recursively checked this original tree. So we passed in our root of 5 and our value of 9. We checked if the root is null, or if the root value is equal to the value. 5 is not equal to 9. 5 is neither null. We check this one is our target value, which is 9, less than our root value 5, false. So you search the right side, is 9. Now 6 gets inputted into here, back at because it's a recursive call because we returned it. Now we have 6 and our target, which is still 9. Recursively check this. This is false. This is false as well because 9 is greater than 6. We return this one, which is the right side. Now we're at 7. Put 7 in here. Put the node of 7 in here, and then the target value of 9. Is 7 null? No. Is 7 equal to 9? No. Is 9 less than 7? No. Then we return this again. Now we're at 9. Now we have 9 here and 9 here. Uh-oh. Is 9 null? No, but we have an OR right here. So then we check OR if root value is equal to value 9, which is the root value is equal to 9. We return the root. We would return all of this right here, starting from here. And then now just to print it, like I said right here, new root is now holding 9. I created this right here, the add subtree, to add the nodes into this new tree. We input the new root into new root, create a new tree, and we say new tree is equal to add subtree. So what this is doing is our new tree is null, our root is null in new tree because we don't have anything in it. It's essentially doing this how I do it step by step here, but recursively in here in a function. So yeah, our new tree is root is equal to null. Root is equal to null right here. So we say if root is equal to null, return. In this case, we returned. Then we say add node. Oh, this is our base case. Sorry. This is if say like we checked 8, we checked left and right, we would return because there's no other nodes connected to this one. This is our base case. Sorry. And then we would just call the add node from the tree function from the tree class, um, which is this one right here, where we're just inputting the value. Um, and in this case, as you can see right here, we have root is equal to add node root value. Um, it would pass in the current root, which is null, and the value, which is root value. Call in the private one right here, which we have root and the root value. In this case, since our new tree is empty, it would do this right here. If node is equal to null, which essentially saying if root is equal to null, return a new root val. So what we do here is it's essentially adding, like I said before, adding it like a new tree, starting from the beginning again, but recursively. Um, so uh what was it? We have 9. It would input 9 as a new root. Then recursively check the left side of 9. We have a value, which is 8. Then recursively check the left side of 8. It's null. We enter this right here. Come back, recursively check the right side to see if there's any nodes to 8. It's null as well. We return here. Um, then we just add 8 because there's nothing else there's null and null here. Add 8, come back to 9. Now we recursively check the right side of 9, which is 10. Now we recursively check the left side of 10, because 10 is now in here. Null, nothing here. That's our base case. Then we check the right side of 10, null. We come back, we can finally add 10 to this tree. So that's what this is doing. Yeah, so let me copy this and show you guys that it also works on Leet code. Sweet. Submit. And I'm gonna submit. Yep, there we go. And this is, oh, I can't see it, but it should be big O of n log n, I think, is the time complexity. But yeah, thank you for watching. Hope y'all understood. And if you have any questions, just let me know. Thank you.